This is a sketch of a Galton board, or a bean machine as it was also called, and this was designed by Sir Francis Galton in England in presumably the late 1800s, 1890, I'm not sure exactly when. And it's related to Pascal's triangle, but we'll have a look at that later. So let's explain how it works. He actually designed this as a board, so it looked more or less like a game, where you have these pins that stops these balls from falling straight down. So these balls are dropping from the top here, and for every peg on the board, it can either go left or right. And if you design it exactly, then you have a 50-50 chance to go either way. Now, we could pretend that this little red ball here has a mind of its own, and whenever it encounters one of these pegs, it has a choice. It can go either left or right, so it could either go this way or it could go this way. And the chance of that is 50% either side. Yeah, but it has to fall down on one of the two sides. So whenever the ball gets down to here, again, it's going to face another peg, and it's either going to fall down on this side or on this side. The same thing happens if it falls down on the other side. But here, when it gets to here, it can either fall down on this side or on this side here. Now we could ask the question, how many ways are there of reaching this peg here? How many ways are there of reaching this peg here? So it could either come down from this end here, or it could come down from here. So there are actually two different routes that the ball can take to get to here. So we could write a 2 here. There are two different ways of getting here. And what about the pegs on the side? Well, there's only one way of getting here. That would mean that the ball has to fall down on this side and then on this side. So there's only one way of that actually happening. So we could write a 1 here, and the same would be the case for the other side. Now we could ask the same question down here. How many different ways are there of reaching that peg? And we could imagine that the ball takes this route down this way. That's one way of getting there. And I'm just going to change color. And another route that the ball can take is, instead of going down the middle, it could go down here and then down here. Or it could actually take this route here and fall down this way and down here. Now, if the ball falls down on this side and this side, it's not possible to get to here. There's no way. So there are 3 open routes, 3 possible ways of getting down here. And the mirror image of this would be this cell next to it, or the next peg. So that's going to be 3 different ways of getting there as well. And if we look at a ball falling down on the side here, it's only going to be one way of getting there. And this is starting to look very much like Pascal's triangle. And it's going to look exactly the same as well. I mean, if we imagine a ball, how many ways are there of getting to this peg here? Well, there's only one way. The ball has to fall down on this side. So that means that there's only one way of getting to that peg. There's only one way of getting to this peg as well. And there's only one way of hitting the peg at the top. And when we talk about that there are more than one way of reaching a certain peg, it means that there's a higher probability that the ball is going to fall down on that peg, then another peg with the fewer roads leading to that peg. Yeah, so there are 3 ways of getting to this peg. There's only one way of getting to this peg, so there's a greater chance that the ball is going to fall down this way. And that's what we see in Pascal's triangle as well. So closer to the middle, the numbers are higher, and closer towards the edge of the board, you have all these ones and lower numbers. Now, I did talk about the ball having a choice of which way to go, and in the next video we're going to look at some strange notation, where this big C actually stands for choice, and we're going to write some strange letters next to that C, and look at what that means. So we can read this as N chooses R, and we're going to look at something else that is going to be strange and foreign to you. This notation, an exclamation mark, which you probably haven't encountered before. We call this factorial, but all that is going to be covered in the next few videos.